Audio. Well, that is fantastic news. All right, so here we go, 6.3.
I was trying to tell you that once, and you told me, no, that was the late one.
Okay, separation of variables. We've been doing this. If you have an original differential equation of x squared plus 3y dy dx equals 0, to separate them, you would first subtract the x squared and then multiply by the dx. So this would finally give you 3y dy equals negative x squared. Whoops, I lost the negative there. All right, then what if I have sine x times y prime equals cosine x? Well, y prime is dy dx, and I could divide both sides of the equation by sine x, so I would get dy equals, and you could actually simplify cosine x over sine x as cotangent x. So my final separation of variables would be dy equals cotangent x dx. I have a third one here. What if I have xy prime over e to the y plus 1 equals 2? Well, I want the y dy's on one side and the x dx's on the other. So I'm going to change the y prime to a dy dx, and I'm also going to divide both sides by x to start with. So again, I changed y prime to dy dx, and I divided by the x. So then you could actually write this as dy over e to the y plus 1 equals 2 over x dx. Now, whether you put the dy in the top or you write it beside it is equivalent. So for the most part, this section should seem way easier because we've really been doing it for the most part for quite some time. So let's look at example 1. It says find the general solution of x squared plus 4 times dy dx equals xy. So the first thing I want you to do is I want you to separate, get the y dy on one side, x dx on the other. So let me give you a head start.
They're huge.
All right, so what I'm going to do here, just to get started, is I'm going to divide both sides by the y, and I'm going to divide by x squared plus 4 and multiply by the x. So do you guys see how I'm getting that? That's just your algebra. I divided by y, so that's where dy over y is coming from. I divided by the x squared plus 4, and then I multiplied by the dx. Then I'm going to integrate both sides of this equation. And then you're going to see a beautiful connection to what we've done in chapter 5 through chapter 6. On the left side, the integral of dy over y would be the natural log of absolute value of y. On the right side, okay, I have a sum in the bottom, so that's a problem. If I had a sum in the top and one term in the bottom I could individually divide, but I can't do that here. So on the right side, I'm going to need U substitution. And let me restate that one more time. If I had a sum or difference in the top with a single term in the bottom, I could have individually divided. But I don't. When I have sums and differences in the bottom, I'm either going to do U substitution or a long division. If the degree of the top is larger than the degree of the bottom, that's when you're going to go for long division. All right, so du would be 2x dx. Well, I see the x dx, but I don't see the 2. So I'm going to divide that out. And the beautiful thing is, as you guys are working on that final exam review packet, this is refreshing your memory as to what we did in chapter 5, okay? So this is 1/2 the integral of 1 over u du. So this is the natural log of absolute value of y equals 1/2 natural log of u plus c. Notice, yes, on the left side you'd have a plus c, and the right side you'd have a plus c, but you would just move the constant to one side, so we only write it once. So this is the natural log of absolute value of y equals, this is x squared plus 4, and I'm going to raise it to the 1/2 power. Okay. All right, now I'm ready to solve this one, and this is where it gets interesting. To solve a logarithmic equation, you need to go from logarithmic form to exponential form. So this is going to go e to the ln absolute value, x squared plus 4 power to the 1/2 plus c equals y. So this is a lot of really solid algebra work. So this is e to the natural log of x squared plus 4 to the 1/2 times e to the c Okay, I'm using that exponent property, a to the m times a to the n equals a to the m plus n power. Now, two things are going to happen here. E to the c is some constant. Now, the other thing is, does anybody remember if you have e to the natural log, they cancel, and then that's just the absolute value of x squared plus 4 to the 1/2 equals y. Now, x squared plus 4 is positive all the time, right? So I don't need the absolute value any longer. The other thing is, the 1/2 power is a square root. So a general solution looks like this, where I have c in the problem. All right, this is one that you're definitely going to want to take time sometime after I've taught the lesson. Whether it's during class, after class, at home, you need to really take your time and go through every step and think about line to line what happened. Why could we do that? Again, this is a college course, so it's called college is called higher education because you do 2/3 of your learning outside of class, okay? So I find students to be very confused when they go to college. They think it's supposed to be like high school, and it's not. It is a much different level. So this is a college course you're in, so it should be a much higher level here. So stop and really look at the right side was a U substitution. Then from here down, this is algebra, okay? Here down, I'm not even doing calculus. I'm just doing a lot of algebra 2 is what I'm working on. Okay, let's look at example 2. I'm going to do a similar process, but this time it says find a particular solution. And what that means is you're going to be given an ordered pair to plug in to find the c value, okay? So What I'm going to do first is I'm going to subtract the xy dx because I'm trying to get the x dx on one side and the y dy's on the other side. Okay, that's always the goal. So it says, given the initial condition y of 0 equals 1. Do you understand that that's a point? Okay, y of 0 equals 1 is really 0, 1. All right, now I'm trying to separate. So I'm going to divide by y, and I'm going to divide by e to the negative x squared. I'm not done separating, because I could simplify on the right side. What do you know about e to the negative x squared when you have a negative exponent? You can pop it up and make it positive. So this is y squared minus 1 over y dy equals negative x e to the positive x squared dx. So on the right side, I end up with no fraction. All right, so one of the important parts of what we're doing is we're solving differential equations. A differential equation is an equation with a derivative. So you're trying to separate y dy is on one side, x dx is on the other. So now I'm ready to integrate. On the right side, I'm going to simplify this. And I just mentioned this with example 1. I said, if you have a sum or difference in the top with one term down in the bottom, you can break them apart. Y squared over y is y to the first, minus, and I have 1 over y. So when you do that, that's easy to integrate. In the right side, or on the right side, if I let u be x squared, du is 2x dx. Well, I have the x dx, but I don't have the 2, so I'm going to divide out the 2. And on the right side, I'm going to pull the negative out, and I have the integral of e to the u du. Because I let u be x squared, x dx I'm replacing with 1/2, and that's a u there. All right, so now let's start integrating. This is 1/2 y squared minus the natural log of absolute value of y equals negative 1/2 e to the u plus c. Well, u is x squared. It's actually impossible to get y alone because I have a y squared and an ln y. So what you're going to do is we're going to plug in the point and find c. Usually, if you can get it to y equals, we want to go the whole way before we plug in. But once in a while, it happens like this one where I can't. So this will be 1/2 times 1 squared minus ln of 1 equals negative 1/2 e to the 0 plus c. So 1/2 minus 0 equals negative 1/2 plus c. If you add a half plus a half, that's 1. So so let's stop a minute here, okay? This one, when you have c in it, that's called the general solution. When you find c and plug it into the general solution, that's called the particular solution. And I'll step out of the way here. So keep in mind, when you're solving differential equations, you will always come up with the general solution first, whether you wanted it or not. You will get it. then you'll be given some kind of initial condition, some kind of ordered pair. You plug in the x and the y coordinate to find the c value. So there's your final answer. 1/2 y squared minus the natural log of y equals -1/2 e to the x squared plus 1. All right, questions on this one? Okay, let's look at example 3. It says find the equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at any point x, y. So we want the equation, so we want something in terms of y equals. But remember, slope is equal to the derivative at that point. So when I have the slope is y over x squared, I can change m, the slope, to the derivative, dy dx. And now we're just going to separate them. This would be dy over y equals dx over x squared. Now I know how to solve this. I'm going to integrate both sides and get the natural log of absolute value of x equals. This is really x to the -2 power. So I increase the power by 1, divide by the new power. So that's natural log of absolute value of x equals -1 over x plus c. This is e to the -1 over x plus c power equals y. So what I just said on example 2 is that one was impossible to get y by itself because I had a y squared and an ln y. But I said if you can get y alone, you want to do that. So in this case, I'm going to go from logarithmic form to exponential form. So this is e to the -1/2 times e to the c. That's c e to the -1 over x equals y. Now we're going to use the point 1, 3. And this will give me 3 equals ce to the -1 over, -1 over 1. Then you multiply by e, and I'm getting c equals 3e. So this is y equals 3e times e to the -1 over x. And I want to show you this is common. Like for us, we can stop here is fine. But if you were to take the AP Calc exam, this would be a multiple choice question, and this wouldn't be one of the answers. One of the answers would look like this. Can you tell how the writers of the AP exam went from here to here? They just built a common denominator and said that was x minus 1 all over x.
Can you go through that side again?
Yes.
I wasn't following you.
Okay, what I did is I took this equation and I plugged in that x was 1 and y is 3. So then I flipped sides too. So I said 3 equals ce to the -1 over 1. So 3 equals ce to the -1, and then I changed e to the -1 to c over e.
Okay.
Okay, that's probably where I lost you. Then to find c, multiply both sides by e, and c is 3e.
Okay.
Okay, yeah. All right, last example is an application. It says the rate of change of the number of coyotes, we're going to call it n instead of n of t, in a population is directly proportional to 650 minus n, where t is the time in years. When t equals 0, the population is 300. That means 300 coyotes. And when t is 2 years later, the population has increased to 500. Find the population when t is 3. So here's the deal. It's saying the rate of change in the number of coyotes. That's dn dt. It's proportional to this difference, 650, and we're just going to, because of all the letters, I don't want to put n of t. I'm going to call it n. So I should be able to read the problem and say the rate of change in the number of coyotes, dn dt, that's a derivative. Rate of change is a derivative. If it's directly proportional, it's k times whatever it's proportional to. And that's 650 minus n. So watch what I'm going to do. This is a differential equation. So I need to separate and integrate. Okay, separate and integrate. I like to skip a step here and just integrate. The problem on the left side is I'm going to need a u substitution. Because it's more than just n in the bottom. If it were just n, I don't need u substitution. So I don't have a negative, so I'm going to need to divide by the negative, and I'm going to get negative the integral 1 over u du. On the right side, that's kt plus c. The integral of some constant dt would be k, we're doing it with respect to time. So this is negative ln, the absolute value, 650 minus n, equals kt plus c. One of the things I need to remind you of back from Algebra 2 with logarithmic equations is in order to rewrite a logarithmic equation, the log has to be alone. There's a negative sign out front. So what we're going to do is we're going to multiply both sides of the equation by a negative sign, and that's going to give me negative kt. And what I want you to do is, technically it's a minus c, but minus c plus c, it's still a constant, okay? Because what you're adding could be positive or negative. So you don't need to make that a minus. It's just this constant. So now, here we go. This is e to the negative kt plus c power equals 650 minus n. I'm hoping at some point, after you've done enough of these, instead of needing to do that extra step, are we cool with saying that c e to the negative kt? You get where that's coming from? Because you'd have e to the negative kt times e to the c. So that's always going to be a c that goes out front. So I'm hoping we can begin to skip that step. Now, I'm going to add n to both sides of the equation and subtract the c e to the negative kt power. Okay, I added n to both sides and then subtracted the c e to the negative kt. I'm trying to solve this for n. Now we have two missing things. So here's the beautiful connection to what we did yesterday and last Thursday. You have two ordered pairs, 0, 300 and 2, 500. You need 2 points to find the c and the k. You need 2 points to find the c and the k. So watch what I'm going to do. I'm going to plug in the first ordered pair. If I do that, 0 times k is still 0. And what's e to the 0? 1. So that's good. So I'm going to get 300 equals 650 minus c. Subtract 650. And c is positive 650. And it was interesting, Eli was talking before the bell rang about he knew he had done something wrong when he was doing that Newton's law of cooling, and it was warmer, it was supposed to be cooling, and he got an answer where it was increasing instead of decreasing. So that jogs my memory here. If you get a negative population, there's something wrong, okay? You made some sort of mistake. If you started with 300, I can't have a negative number. So this is the initial, some kind of initial amount. So this is 650, n equals 650 minus 350 e to the negative kt power. Now we have a second point that we're going to plug in. The n is 500. And that's e to the negative 2k power. Let me give you a head start. Use your calculators. How many of you are going to be absent on Friday? 1, 2, 3, 4, 5. Only 5? Okay.
I might.
You might? Okay. Alright.
So tomorrow's just food day?
Food day, work on homework, yeah. And then Thursday, Friday are both like workish days. Because you should have a 6.3 worksheet. But I'm going to give you tomorrow to work on that. Then you do have, does everybody have, there's 2 other worksheets, okay? So, yeah, no, today's Tuesday, right? Okay. 6.3 worksheet is due Thursday. Then on Thursday, you're going to do the review. It says review 6263. And then on Friday, you have a paper that says worksheet on differential equations. That's the Friday paper. And the answers are on the back of that one. Monday is my understanding is senior skip day. And then Tuesday will be our quiz on 6.2 to 6.3. All right, are you guys getting K is about 0.4236?
Can you work that out? Because I don't know exactly,
Yeah, sure.
like, what step to do.
Okay, so here we go. If you would first subtract 650, you would get negative 150 equals negative 350 e to the negative 2k. Okay, divide by negative 350. I got my calculator because I oftentimes do a lot on my calculator. All right, so you're getting 0.42857 equals e to the negative 2k.
And then you just take the natural log.
Take the natural log. Divide by negative 2. And k was this, it's positive, 0.4236. So then n equals 650 minus 350 e to the negative 0.4236t. Then it says find the population when t is 3. So you're going to just plug in that t is 3 there. And when I did that, I got 552, and that's coyotes. I need you to find the 6.3 worksheet. It's stapled because I have a couple of typos that I need to fix. I don't know if I fixed it before I printed it or not, but I wrote a note on here, so let's check it. Find the thing, it's stapled, and it says 6.3 worksheet. Okay, find the 6.3 worksheet. It's stapled.